Today is May 13th, and we are going to look at how to find the number of possible outcomes if we have independent events and dependent events. And to do that, I'm going to refer back to what we did on Tuesday, and these are actually notes from Tuesday where we were looking at combination locks. And we said, for example, on this first one, that it had a three-digit combination, and in the first digit there were 10 options, the numbers from 0 to 9, and in the second position there were also 10, and in the third position there were also 10. So those would have been independent of each other. So the number on each of those dials would have been independent of the other ones. In other words, it could also repeat. So if I had a 1 on the first dial, it doesn't exclude me having a 1 on the second dial. There are things where they're dependent on each other. So if I had a 1 in the first position, sometimes I can't repeat a 1. So I have to have different numbers. Sometimes it's referred to as unique numbers. Sometimes the situation just tells you that you can't repeat. So think about the video you just watched from TED Ed, and when people were sitting in the chairs and we were looking at the different combinations, or when we were looking at a deck of cards and we were looking at the different combination of cards that we're using. And you can't, once you use a card, you can't use it again. So those are dependent events. So depending on what happens first will limit the options for what happens next. So we're going to look at these lock problems again. I know you just looked at a couple examples of this on the TED Ed video. So I'm going to leave these examples of these independent events here from the other day, but now we're going to add on to it dependent events. So again, if I had this first lock, I had 10 possibilities in my first position, but then if I have to use different numbers or unique numbers, in my next position I would only have 9 options available because one of them would be gone. And then in my next position I would have only 8 options available because 2 of them would have already been used. So that reduces my number of possibilities to 720 combinations. On the next one, if I have a lock numbered 0 through 39, when I first spin the dial, I have 40 numbers I can choose from. But if my lock said, the way that it was made said that I couldn't repeat any of those numbers, I had to have different numbers, then it would be 39 and then 38. Now notice that these are not totally factorials because they don't go all the way down to 1. So in the TED Ed video you just watched, they talked about something like 40 factorial, but that would be 40 times 39 times 38 times 37 times 36 times 35. It would go all the way till 1. So this is actually like the beginning of a factorial, but not, I cannot write this as 40 exclamation point. That is not accurate. I'm not going to calculate this right now because I want to make this video quick since you've already just watched one. But that's how this would change. And then on the final one, if I can't repeat numbers or letters, I want to be really careful on this one because my first wheel is numbers, so I have 10 possibility. My next wheel is letters, so I have 20 of them. My next wheel is actually different letters, so I still have 20 options because I can't have used any of these letters over here. But if I have no repeats, on wheel number 4, I'm using the same numbers as I did on wheel number 1, and I would have already used a number here, so this would change to 9. So you want to consider each situation individually in determining whether you are using the full number of choices or if one of your options is reduced because that possible outcome is dependent on what has already happened. So that's another quick look at determining possible outcomes. Your assignment now is going to look at a variety of different problems related to, we use the word combinations very loosely. These are actually they're actually permutations. And when you get into a little bit more sophisticated work with combinations and permutations, you'll understand the difference between them. And for those of you who like to challenge yourself, I would say do a little bit of study online with combinations, permutations, and factorials.